Hello, can you see my screen?
Yes, it has PowerPoint with face sequence being
Yeah,
displayed.
yeah, yeah, great. Yeah. Okay, everybody. So today, basically, we'll be discussing few numerical problem, practice problem based on three-phase circuit and the Fourier circuit analysis. But at the beginning, I like to continue discussion about three-phase system. So an important topic which is called phase sequence. And I have written in parentheses positive and negative. So what is that? Everybody see the below diagram ABC or positive sequence. So you know that VAN, then after 120-degree VBN, then again after 120-degree VCN, or in anti-clockwise, it is plus 120-degree. So we discussed this concept in the previous classes. You know this one. So this means ABC, we are calling that is the positive sequence. And this is the sequence that is followed in United States. Now, there are some situations, or some other countries that might use ACB. That's why I have written here ACB or negative sequence. So ACB sequence means this is reference VN, phase angle 0. Then after 120-degree, C phase. I mean, here ABC, B phase comes after A phase, but in the ACB sequence, C phase comes after after A phase. This means VCN is lagging by VAN phase minus 120-degree. And then again another 120-degree, that is B phase, VPN. Or in anti-clockwise, B phase has plus 120. So as you can see that these two sequences are opposite. It is like ABC and here it is ACB. So now see this diagram. I mean, I have written phase rotations. Like ABC phase sequence means the peak of A phase will come first. Then after 120-degree, peak of the phase B comes. Then another 120-degree, the peak of or amplitude of phase C comes. That is the meaning of ABC. And so at the bottom, this is ACB. See, the peak of A comes, then the peak of C comes, not the B phase. B phase comes after 120-degree. So this is the example of ACB. Now, why I am discussing this thing, I mean, what is the issue? That, for example, as I mentioned, that United States has ABC or positive sequence three-phase system. Now we have a system and you purchased or you have brought a device, three-phase device that has ACB sequence. And then you try to connect with the existing system here with the ABC. So there will be some issue because the sequence does not match. So there will be some sort of circulating current flow among phases. And that circulating current will cause some sort of power loss. It will cause some heating. Gradually, the device might be burnt out. So there are adverse or negative impact of having different sequences in a particular system. Same thing, as I mentioned, the country that adopts ACB phase sequence, and there if you bring a device or if you take a device with the phase sequence ABC, and if you connect to their system, again there will be issue. So in fact, there are some conditions to connect to system together. For example, in United States, for single phase voltage, it is 120. Now in other country, it is 230 volt. So now if you have a device with 120 And if you try to connect to their system, then that will cause problem. Similarly, in United States, frequency is 60 hertz, but in Europe and in Asian countries, they have 50 hertz. Now, if you try to connect two device that has different frequency, even the voltage might be the same, but still there will be issue. So this means that phase sequence must be the same, voltage must be the same, phase angle should be the same, and frequency should be the same. If it is not, then there will be some sort of circulating current, and that will cause heating, power loss, even the system breakdown. So that's why this phase sequence things, positive, negative, it is important. Now, here you see that I have brought in the next three bullets, I have written on new things like zero sequence. You see here, zero sequence, zero sequence. So zero sequence means like positive, negative, zero. I have written on thing, that with the help of symmetrical component tool, an unbalanced three-phase system can be decomposed into three-phase balance systems having positive, negative, and zero sequences. Okay, so what does that mean? Symmetrical component is a kind of instrument, or it's an analyzer, mathematical analyzer. For example, you have an unbalanced system. It is three-phase. It is maintaining either ABC sequence or ACB sequence, but it has been unbalanced. Voltage magnitude among all three phases are not the same. So now to analyze that unbalanced system, you need to take the help of the symmetrical component tool or mathematical analyzer. It will create three sets of balanced system. You have one set of unbalanced three-phase system, but symmetrical component will divide it into three different balanced system. One, one will have positive sequence like this type ABC, other will have negative ACB, and third group will have zero sequence. Zero sequence means they will not have any 20-degree phase difference. They all will have the 0-degree phase difference. This means there is no phase difference, but there will be the same magnitude of voltage or the current. That is called the zero sequence. So therefore, clearly you can understand that zero sequence is kind of the new or the extra or additional current that is present in an unbalanced system. And what will happen with that zero sequence current? See the last bullet. During any unbalanced fault, for example, you have a three-phase system and there has been some sort of short circuit between two phases or just one phase got affected. That is the example of unbalanced fault. If there is any unbalanced fault and if the system is Y connected, because Y connected system has neutral, that zero sequence current will flow through the neutral. And then as you can guess, the consequence of flowing that zero sequence current through the neutral, because that neutral will be overloaded. Neutral line is not supposed to carry any current. Neutral line is not designed to bear or to carry any current. Now, because of the unbalanced what happened, and that has caused unbalanced three-phase system, and consequently, you are getting zero sequence component. Where that current will go? That current will flow through the neutral. So consequently, neutral will be overloaded, overburdened, and not only that neutral line of that system will be overloaded, that system might be connected to other system. Like, for example, you have a three-phase system and there is another three-phase system nearby. Again, there is another three-phase system. All three-phase system have the neutral line provided that those are Y connected. So in case there is any fault in any of the three-phase system, then zero sequence current will start flowing through the neutral, and that neutral current again start flowing through the other neutral. This means consequently all systems will be overloaded, there will be heating, power loss, and even the system might be damaged or broken. So that's why this page sequence thing is important. And I have brought to you, I mean, if you read the book or any literature, you will be getting these terms: positive, negative, and zero sequence. And also, if you are asked the question, even in this course, what is the impact or what is the consequence of having unbalanced system, then you can mention that the last bullet point, that is the main point, that if the system is unbalanced, then there will be zero sequence current or there will be some sort of circulating current flow through the neutral of Y connected system. Now, if it is delta connected system, as you know, because delta connected system does not have any neutral line, so what will happen? That zero sequence current will be trapped, will be blocked by the three coils in the delta connection. So therefore, gradually, those coils will also be, overheated and might be damaged. The Y connection is more dangerous because it has neutral, and that zero sequence current or additional current will flow through the neutral, and that might affect the other neutral, that is dangerous. But even the delta connected system, um, although there is no neutral, but still the all of the three phases or coils will be heated up and the system might be damaged. So that's why you see in the middle bullet I have written, with respect to positive sequence, for example, United States has positive sequence. With respect to United States, negative and zero sequences are not desired because they will cause some problem. Uh, Everybody, do you understand what I told?
Yeah, makes sense. Good
Yeah.
stuff.
Yeah. Very nice, and you will be remembering. I mean, again, as I like emphasize the AP exam, just you might get on questions from this slide. Okay, what is the impact or what is the consequences of flowing zero sequence current? Then just you mention the last bullet. I mean, that is the perfect answer. Okay, so moving forward, today will be some exercise or practice of three-phase system as well as the Fourier series. Okay, so everybody see, here I have set up on a simple problem with respect to three-phase system. What I have written, a three-phase motor can be regarded as a balanced Y load. So this means there is a three-phase motor, for example, at your home, and that is balanced, but it is Y connected. This means it has a neutral line. Now then I am telling that a three-phase motor draws 5.6 kilowatt because it's, you know, that motor, so it is you plugged in and it is taking power from the line. So, and what's the line voltage? 220 volt. So everybody keep in mind that when I am saying line voltage means line to line voltage. I mean, in literature, in electric book or the circuit book, line voltage refers to line voltage. I mean, sometimes in some book or literature, you will be getting clearly line to line, and in most cases, simply line voltage. That is basically line to line. Okay, and then the line current is 18.2 ampere. Then determine the power factor of the motor. So at what power factor the motor is running. So therefore, just by looking the problem, so because you see the power rating is given, voltage value is given, line current value is given. So real power P root 3 VLIL cos theta. Can you remember that in the last class for three-phase system we are discussing, and we showed this equation root 3 VLIL cos theta. So therefore, on the left side, p value is 5.6 kilowatt. I just converted into watt. by multiplying it 10 to the power 3, and then right side root 3, then VL value and IL value, and then that cosine theta. And you know that that cosine theta is actually the power factor that you have to determine. So here you see cosine theta equal to this divided by this. So finally value is 0.8075 approximately. So everybody is fine. This is, I mean, simple problem.
Yeah, that was the easiest problem.
Yep.
Yeah. Just I wanted to show you the application of this equation, and then everybody just keep in mind root 3. It is not like three-phase system, so 3 VLIL cos theta. Many times in my past experiences, students make mistakes. They write this equation, they use properly VLIL cosine theta, but then they put here like 3. That is wrong. Keep in mind it is root 3. Even the reactive power Q, root 3 VLIL sine theta. And then when we are using root 3, when we are using the line quantity, like voltage and current are expressed in terms of line. But you would be right if you put 3, provided that you put VP, IP, phase voltage and phase current. In that case, for a balanced system, you can multiply it by 3. So here is the difference. I mean, everybody will be careful by using this root 3. Okay, the next problem. Everybody see this example. Calculate the line currents in the 3-wire YY system of the following figure. So in this case, 3-wire means 3-phase. I mean, I have used the term wire, but basically this is 3-phase. So everybody see the diagram. On the left side, it is Y connected system. This represents voltage source having on 10 and 0 degree voltage. Then the B phase on 10 minus 120, and then leftmost side C phase on 10 minus 240. And then can you tell which phase sequence is this? What's the phase sequence? Nathan?
Why do you go to me?
Be the positive sequence
Yeah,
ABC.
positive. Yeah. Positive.
Yeah, it's
Yes.
positive.
Yeah. I mean, why I'm emphasizing this on, because in next slide, when we'll be doing problem, we will be calculating for phase A, and then just we will not do full calculation for phase B and C, but by looking positive sequence ABC, we will conclude. I mean, that is the significance of having this phase sequence concept. Okay, anyway, so and then as you can see, those 3-phase Y-connected system is providing power to the load. Again, you see, the loads are connected in the Y fashion. So this means this is Y-connected system. This is the common point. And then these are called the line impedance. So you see the line impedance in all 3 phases, A phase, B phase is the same. In the Y-connected load, all 3 impedances are the same. And this is the ABC or the positive sequence. So this means this is fully the balanced system. There is no any unbalanced situation. If, for example, here these would be different, then that could make the unbalanced. Or these lines would be different impedance, then that would be the unbalanced system. Okay, so therefore the question is how much line current is flowing. So you have to find out, for example, this current or this current or this current. So therefore see the next slide. So again, I have redrawn. Here I have put the neutral. Everybody see on the source side, the common connection point is the neutral. So I have put in similarly on the right side, because it is neutral. Sorry, it is the Y system. So of course there is neutral N prime. So therefore, I mean in real practice, this N prime and N will be connected. I mean, they will be sharing the same common path. And finally, that will be grounded in the system. So the question is, you have to find out line current. So what I have did here, that because this is a balanced system, so what I can do, I can make a equivalent circuit like single phase system from phase A. So as you can see, N, this is N point, and this is that A point. There is a source Vn, which is that 120 degree, and then this A, and then this neutral point. I have put the combined impedance here by the name Gy. This means Y connected system. What is the total impedance? So therefore, for phase A, you could make this type of simple series circuit. Now, what is the current IA? So therefore, if you see this single phase diagram, IA is Van over Gi. And what is that Gi? Gi is, you have to see from this point to this point. So 5 minus J2 plus that 10 plus J8. So therefore, this is the total impedance. So consequently, the current flowing IA is this one. Now you see, this is the thing that I was telling. I was asking that what's the phase sequence. So you told correctly that that is the ABC or positive sequence. So IB, what I am doing, once I get IA, IB will be minus 120. That's why I have written that IA with angle minus 120. So therefore you see here, IA has angle minus 21.8 degree. So then minus another 120, minus 140, 1.8 degree. Similarly, for C phase, minus 240. Therefore, finally it is minus 261.8, or in other words, in clockwise, 98.2 degree. So therefore, you know that for phase B, for C, we are not calculating magnitude because it is the balanced system. So you will be getting the same magnitude, just you have to consider the proper phase angle. So everybody is fine?
I have a question.
Yes.
So are the currents all I guess it's a couple questions actually. So in a balanced system, are all of the impedances on the individual networks going to be the same?
Yes.
Or
If it is balanced, it must be the same.
okay, got you. So that's why you can just do the angle difference and come up with the current.
Exactly.
Okay.
Exactly. And
Yep.
that is the reason I was asking you that question, simple questions, what's the sequence here?
Yeah, I knew the answer, but I just laughed because I don't know why, it just made me laugh really hard.
No.
Yeah.
I understand. So I know that you all could answer that question. So I was just making you all alert of it. That's why I mentioned your name.
Yeah. Yeah, no worries. That's good. Thank you.
Yeah. Okay. So therefore, I mean, because you will give the midterm exam third next week, I think April 24th, next Friday. So definitely you might expect on very similar problem to this one. I will just change the values. And even in the final exam, you might expect, and these are like pretty standard problem. Again, you might face exactly the similar questions in the FA exam. Okay, so then moving forward, as I told that today, like we are practicing. So again, like I'm going back to the Fourier series. In last class, we solved, I think, one or two problems, but today I have brought a different function. It's rectangular form or square form. The question is find the Fourier series of the following square waveform. So everybody see the pattern. So what's the time period? Is it 1 or 2 of this signal? What's the time period T, capital T?
Would it be 2?
Yes, exactly. Because everybody see it is the function and then going negative side. So after 2, again it is repeating. So this means that this is the total time period, 2. It is not 1. So, okay, so now everybody see the calculation. That is the thing. First I have written T is 2 time period. And then I am calculating omega naught fundamental frequency in radian per second, which is 2 pi over T. And then I plugged in T equal to 2. So 2 cancelled, and then that is the phi. Now, because it is Fourier series, so you have to calculate A naught, An, and that Bn. So everybody see what is A naught? 1 over T integration of 0 to T ft dt. So this is the basic formula that we derived in the last class. And then I am plugging in those given values 1 over T. So time period is T, so 2. Now, inside there are two parts, The function is 1 when it is time period is 0 to 1, but then it is -1. You see this side is -1 between 1 and 2. So that's why I have divided into two components, 0 to 1, 1 dt, then plus again another integral. Lower limit is 1, upper limit 2, -1 dt, because function value was -1. And then, this is, simple function. So after integration, it is t, limit is 0, 1. And then I have put this minus sign here, t, and then limit is 1 to 2. Then if you put the limits, finally it will give you 0. Now, here you see, I am calculating an. So this is the first basic definition of an. 2 over t integration of 0 to t function of t multiplied by cosine of n omega naught t dt. This is the basic definition. Now again, that function of t, it has two parts, +1 and -1. So I decomposed into two parts. But as you can see, because here's there as cosine of n omega naught t, you can substitute omega naught by pi. So that we calculated above. So this means cos n pi t. So after integration, it is 1 over n pi sine n pi t, limit 0 to 1, and then minus sign. Again, here also it is sine n pi t, limit is 1 to 2. Because all sine function, so sine n pi, when you will put the value of t1, still it will be 0. Sine 0 is 0. Even on this component, sine 2n pi, that is also 0. So you see, we have those equations. I think I have written here. Everybody see this slide. Here you see sine 2n pi 0, and then sine n pi is still 0. But cos 2n pi is 1 and cos n pi is -1 to the power n. I think you can keep these things handy in front of you. Last class also I made this slide available. Anyway, so moving back, so therefore this also gave me the 0. This means for this function a naught 0, n 0. Now see what happens with the bn. So here is that bn calculation. Again, this is the general equation, but in this case it is sine. So again, I am calculating between 0 to 1 and 1 to 2. But in this case, because there is sine, sine, so you will be getting cosine, cosine. And now if you plug in those 1, 0, 2, 1, those will not be 0. You will be getting those values after applying those trigonometric identity. Finally, the last line is 2 over n pi, 1 minus 1 to the power n. And then now n values could be 1, 3, 5 or 0, 2, 4. So for even values, for even number, always you will be getting +1, so it will be 0. But if you choose n word like 1, 3, 5, then you will be getting minus. So then minus minus will be plus. So you will be getting it 2 here. So 2 to 4. So 4 over n pi. So this means for this function, a naught was 0, a naught 0, but bn has 4 over n pi. So finally, function of t is 4 over pi. I have written in inside. summation of k equal to 1 to infinity. I have introduced the term k sine n phi t, provided then n equal to 2k minus 1, k equal to 1, 2, 3. So this is the final answer. So everybody understands?
Yeah, that makes sense.
Yeah.
If I wrote that as sinc of n, what would it be, n pi t? Would that be okay as well? For
Yeah,
the
yeah,
answer?
that will be okay. That will be perfect.
Okay.
Yeah, that is also okay. Because I mean, what is the reason writing in that way, k equal to 1.1? Because you know that we got 4 over n pi when n equal to odd only, like 135. But here we want to put a variable so that it starts k 1, 2, 3. That is the reason. Sometimes mathematical representations is expressed in that way. That is only the reason. But absolutely, you are right. If you end up here, then that will also be fine. And then everybody, again, after the class, you make practice on your pen and paper. You see that you start from here and you do yourself and you see that you can reach here. You are getting the same thing. Okay, so moving forward. So another example. You see, in this case, it's different type of waveform. It is called sawtooth because it looks like that divides the saw or teeth type. That's why. So find the Fourier series of the sawtooth waveform in the following figure. So here, I mean, what's the time period? Time period is 1 because after 1 it is repeating. But so what is the function value here? This level is 3 here on the y side. This means this distance is 3. So that's why, you have to use y equal to mx, that equation, where m is the slope. So this means that your slope value is 3. So you will be getting function value 3t. Therefore, everybody see, when I am calculating a naught, 1 over t, integration of 0 to t, function of t dt. So 1 over 1, t value is 1. But everybody see, function value is 3t. That is the catch point. And that's why I have brought this problem in front of you. It is not just 3, it is 3t. And as I explained, that is coming from y equal to mt, where m is the slope. So and then limit is 0 to 1, and then you see 3 is constant, then integration t square over 2, and then limit is 0 to 1. So finally, after putting it upper limit and lower limit, you are getting 3 by 2. Now come back to the an. So an is 2 over t, and then 0 to, this is the basic equation. And then I am going. Now here it is important. The function, everybody look, the second line. This 3 will go, it will be multiplied with 2. So I made it 6. But here what is 0 to 1 integration t multiplied by cosine of n 2 pi t. So what will be the integration? How would you integrate? So it is called integration by parts. It is the multiplication of two functions. One is t, other one is cos 2 pi n t. So therefore you see, I have written 1 over 2n pi squared cosine of 2n pi t plus 1 over 2n pi t multiplied by sine 2n pi t. So therefore, how I got that? Again, see those equations. Everybody look these two. Integration of t cosine of at dt. So what you are getting? 1 over a squared. This means that a was with the cosine. That is the argument of cosine a. So 1 over a squared. Then cosine at plus 1 over a t sine of at. But if it is the sine function, then it is 1 over a squared similar, but then there is a minus sign here, 1 over a t. So therefore we have to apply these techniques there. That I did. So therefore everybody see the third line, I exactly applied that. And then you put upper limit and lower limit. If you put, it will give you the 0 value. Similarly, for Bn, it is 2 over t, and then 0 to t, 3t sine n omega naught t. This is the general formula, but then you put it, you multiply 3 with 2, so it is 6. But then this is t sine of 2n pi t. Then similar to that cosine function, I am using that trigonometric identity, basically integration by parts. But here there is a minus sign. That is the catch point. And then again, if you put upper limit on lower limit 0 here, but in this case, everybody see, you are getting a value which is minus 3 over n pi. It is not 0. So this means you got a not 3 over 2 and 0, but Bn has value minus 3 over n pi. So you see the last expression, finally, function of t, 3 over t minus 3 over pi, n equal to 1 to infinity, 1 over n sine 2 n pi t. Everybody understands?
Mhm.
Yeah.
I had a
Yeah.
question.
Okay.
Yep.
Yeah, going back to the beginning, how did you get that 3t again?
Ah,
You did
okay. So everybody please see the function. You see here, this is your time period, okay? So from here to here, distance is 1. And what is the this amount? This amount is 3. Now, because there is a slope, we have to use the geometry slope equation. What is the slope equation? This is a straight line passing through the origin. So what's the equation? Y equal to mx. Rosman, could you remember that equation?
yes,
Yeah,
sir.
yeah.
Mx plus b.
Yeah. Mx plus b when the function does not pass through the origin.
Okay.
If this function would be passing through a little bit up, then you are right, y equal to mx plus b. But it is passing through the origin, 0 point, so y equal to mx only. Now m is the slope. What is the m? M equal to y over x. What is the y value? Y value is 3. What is your x value? X value is 1. So that's why it is 3. So the finally function is y equal to 3t because it is the function of t.
Okay.
Does it make sense?
Yes, sir.
Yeah. So that is the 3t. So very good question. So I like that you asked that question, and that is the reason I brought this function in front of you, so that like you are familiar with all type of function. So everybody see this 3t. Is there any other question on this slide? Definitely, you might expect on very similar problem in the upcoming midterm exam as well as in the final exam. Okay, so moving forward, this slide is just those identities. Now, for today, this is the last slide. Everybody see, again another circuit problem with the help of Fourier series. What's the question? If the sawtooth waveform shown in figure 1, this is figure 1, is the voltage source VST in the circuit of figure 2. So in this circuit, there is a 2 ohm resistance and 1 farad capacitance, and input is VST. So statement says that VST is this function. This sawtooth waveform is applied VST. Then what should be the response V0 t? So therefore, as you can see, we just solved this problem in the previous slide. That's why I have brought to you here this type of function. So this is the input function for VST. So this means first you have to make the Fourier series, and just now we did in the previous problem. So you see, now see the calculation. On top I have written that function that I got, like 3 by 2 minus 3 by pi summation n equal to 1 to infinity 1 over n, that function. That will be getting from here after Fourier series. Now everybody see the solution. I have redrawn the diagram. Your goal is to find out V0, provided that that is the input, that is the Vs. Now, everybody see what I am doing. First, I am making this circuit. I am converting this circuit into phasor domain. So what I did, 2 plus, this is capacitor 1 over j omega c. So therefore 1 over, in this case, omega n, because there is nth term, that's why I am using in terms of Fourier, 1 over j omega n, and then c value is 1. And then you see the next line, it is j omega n, but you are getting 1 plus j2 omega n. Now come back here, see my calculation. You need to calculate V naught T. So just this is simple circuit. Apply the voltage divider rule. So this means that Vs over impedance first. So this was the total impedance right side. So that's why 1 plus j2 omega n in the denominator, but j omega n goes in the numerator. So this is the current, and I am multiplying by the impedance. That gives me the voltage. So therefore j omega and cancelled. I got V naught is Vs over 1 plus j2 omega n. So everybody understands this calculation?
So far, so good.
Okay, great. So now everybody see in the output function, output expression, there is Vs. This Vs is basically that topmost, that function. Now it has two parts. One part is DC, just constant, 3 over 2. And then this is the sinusoidal expression, sine function. So I am writing, everybody see, when V is equal to 3 by T. So in this expression, V naught T expression, plug in that number, V is 3 by 2. But because this is DC, so DC has 0 frequency, put omega value 0 in the denominator. So therefore this term vanishes, only like 1 remains. So ultimately you are getting V naught 3 by 2. So therefore this is one way of understanding this. Other way of understanding is that if you apply 3 by 2 voltage here, which is DC, so you all know for DC, capacitor is open circuited. So what will be the voltage? That voltage will be applied here. So that's why simply it is 3 by 2. Okay, now the Vs has second component, this one, 3 over n pi sine 2 pi nt. So everybody see, Vs, I have written that, but I converted into cosine after putting minus 90 degree, so that I can express in phasor form or polar form 3 over n pi angle minus 90 degree. So now this means now this is your voltage. Now plug in this voltage Vs value into this equation, V naught equation. So everybody see, V naught T for Vs, I plugged in this number 3 over n pi minus 90. But everybody look, in the denominator, it was like 1 plus j2 omega n. I calculated its magnitude, root over 1 square plus 2 omega n squared. So I am getting 4 omega square n square. And what's my angle? Tan inverse 2 omega n over 1. So tan inverse 2 omega n. Everybody could follow me?
So
Yeah.
far.
Yep.
Okay, great. And then see the next line. This numerator is fine. In the denominator, what I did, root over 1 plus, I substituted the omega value by 2 pi. So if you remember the previous slides, when we were calculating this function, we got omega naught value is 2 pi. Because 2 pi by t, t was 1. That's why I have substituted omega by 2 pi. So that's why 2 pi squared and n squared. And tan inverse, again here I substituted omega by 2 pi. So 4 pi n. Now in the next line, you see what I am doing, 3 minus 90 degree there. But everybody look, in the denominator, it was tan inverse 4 pi n angle. So I am putting in the numerator. So that's why this minus 90 minus this on tan inverse 4 pi n. And then this 3 is this 3. N pi goes in the denominator. And then in the denominator, like root over 1 plus. From 2 pi square, you are getting 4. So 16 pi square n square. So therefore, kind of you are done. Now, what is your expression? V naught t. That first you got that 3 by 2, then minus 3 by n pi, and then root over this one, and then cos 2 pi nt, then this angle minus 90 degree. So therefore, you can keep this one. This will be the correct answer. In next slide, I have just converted into sine function. That's all. So everybody understands the calculation?
Yeah, it makes sense. We've done this in signals too, so it's kind of a little overlapping.
Oh, okay, got it. Yes, signals too. Yeah. So,
So were you combining basically the one we did before with the same signal, just adding it to the circuit?
Yeah. Right. So for example, this is the function of t at the beginning. That signal is applied
Yes.
as the Vs. Now it has two components. So that's why I'm calculating twice. One, I'm assuming that okay, only 3 by 2. Next time I'm assuming that okay, this is the signal that is applied. If there is one more term, then again you have to take into account that one. That's the thing.
Okay.
Okay, so I think that's all for today. So I recommend you all, please, you again look. I mean, today's these problems and then previous classes problem, Fourier series and three-phase circuit. So then, and then I think today you have the due date to submit the homework 5. Basically for that magnetically coupled circuit problem. So therefore, with that, today I think basically I am done in terms of syllabus. We don't have any new chapter, like three-phase circuit was the last chapter. So I am done. So before your midterm third exam, we have 3 more classes like Friday and next week Monday and Tuesday. So therefore next 3 classes, I will be going over that midterm exam 2 questions, and then your today you will be submitting the homework file that I will also be going over. I will let you know the grade, and we will be concluding by next Wednesday, so that you are fully ready with the midterm exam 3 as well as the final exam.
Will there be 3-phase systems on the midterm exam?
Yeah, definitely.
Will we get a homework assignment before then, or are we just gonna
Yeah,
review it?
no, I will return before that. Therefore, today, because today you will be returning me the homework file, definitely I will try to return it by Monday. Everything I will be trying to, I mean, midterm exam 2, I will be posting the solutions for the homework 4, homework 5, everything I will make available before the midterm exam 3.
All right, sounds good.
Yeah, this means that by next Wednesday, everything will be ready for you. Just you need to look the slides, understand, make practice, and go for the midterm exam as well as then the final exam. So you'll be ready. Okay. So is there any questions, comments from anybody?
And here.
I think it's all good.
Okay, so thank you. If there is no, so then now I am stop sharing the slides. So everybody, so then thank you for joining the class, and have a good day. I hope you have a good day, and then everybody please be safe. So,
All right.
so
Sure, have a good one.
Okay,
Thank you,
thank
Dr. Ali. Have a good one.
Okay, thanks. So see you on Friday.
All right, bye.
Bye.
Have a nice day.
Same to you. Bye.